Welcome back to Learners Academy. Today in the series of finding volume and surface area of three-dimensional shapes, we are going to learn volume and surface area of cones. Cones are fascinating three-dimensional shapes, often found in everyday life from ice cream cones to party hats. Understanding the geometry of cones helps us explore their volume and surface area, which are two essential properties. Now let us dive into the basics of cones. A cone is a three-dimensional shape that has a circular base and a pointed top called apex. Imagine taking a flat circle and smoothly pulling one point of the circle upwards until it forms a cone. The height of a cone is the perpendicular distance from the base to the apex. The slant height is the distance from the apex to the point on the edge of the circular base. The volume of a cone tells us how much space is inside the cone. You can think of it as the capacity of the cone. If we compare the volume of a cone to that of the cylinder, then the volume of a cone is 1/3 of the volume of a uniform cylinder with the same height and base radius. The formula for the volume of the cone is 1/3 into base area into height, or mathematically 1/3 into pi r square into h. I hope by looking at the formula you should remember that the formula of the volume of a cone is similar to the formula of volume of a pyramid, which is also 1/3 into base area into height of a pyramid. Surface area of the cone is sum of all the areas of the surface of the cone. Can you identify all the surfaces of the cone? You can pause the video and give it a try. The surface area of the cone is the total area that covers the surface of the cone. It includes two parts, the area of the cylinder base and the area of the curved surface that wraps around the cone. To find the formula of the surface area, we have a base circular area having radius r and an area of sector having the radius of length L, which is equal to the slant height, while the arc length of the sector denoted by letter C, which is same as that of the circumference of the circle of the base. C is the arc length of the sector equal to the circumference of the base circle. The formula of sector area or curved surface is half into arc length into slant height, or 1/2 into C into L. As the value of C is same as the circumference of the circle of the base, we can say that C is equal to 2 pi r. Putting the value of C in the formula, we get an area of curved surface as pi rl. Since the area of the base circle is pi r square, therefore the total area of the cone is sum of the areas of the curved part and the base area of the cone. Mathematically, it comes out to be pi rl plus pi r square. Upon taking pi and r common, the formula becomes pi r into sum of L and r. There are some cones that are not solid from the base. Instead, the base surface is missing and only curved surface is present. Example of such cones are roadside traffic cones. Such cones are called as open cone. To find the surface area of open cones, we will take the surface area of curved surface only. Therefore, the total area of open cones comes out to be pi rl. In the end, let's go back and see what we have learned. The volume of the cone is 1/3 into pi r square into h. Similarly, surface area of cone is pi into base radius multiplied by sum of slant height of the cone and base radius. Mathematically, it can be denoted by pi r into sum of L and r. Mathematically, it can be denoted by pi r into sum of L and r. Lastly, the surface area of the open cone is pi into base radius into slant height, or pi rl. I hope you will take some time by pausing the video and memorize the formula. Let's do a couple of examples to brush up your concepts and prepare for the tests. In this example, we are given the base radius and height of the cone, and we are to find the volume and surface area of the cone. Formula for the volume of the cone is 1/3 into pi into r square into h. By putting the value of r and h, which is already given, we get the volume of the cone as 2093.33. For surface area, we have the formula pi into base radius into sum of base radius and slant height. But we do not have the value of slant height, right? So to find the slant height, we use the Pythagoras theorem on right angle triangle having L as the hypotenuse, H as the perpendicular and R as the base. So L square is equal to R square plus H square, and by calculating it, L comes out to be 22.36. Now using the surface area formula, which is pi R into sum of R and L, we get the value of surface area to be 1016.104. Let's do another example for gaining more confidence. Here we have the base radius 4 and the slant height 10. while we are asked to find the volume and surface area of the open cone. I hope you have registered the keyword open cone as it has no base area. By now you should be smart enough to figure out that the height of the cone is not given. Height is the essential part for finding your volume of a cone. The formula for the volume is 1/3 into pi into r square into h. Coming back to finding the h, can you think of a way of finding h with the given parameters? Yes, we use Pythagoras theorem on the triangle having slant height L as the hypotenuse, R as the base and H as the perpendicular. Rearranging the variables and we have H square equal to L square minus R square. On plugging the value of L and R we get H square is equal to 84. H is calculated by taking the under root, which comes out to be 9.165. So now we have R and H for the volume, and we know the formula of the volume of a cone, which is 1/3 into pi r square h. Plugging the value of pi, r and h as shown, we get the volume to be 160.77. For surface area, we have a slight change in the formula as there is no base area. Therefore, surface will be equal to pi rl, which is the area of the curved surface only. Using the values, we get the answer to be 628.38. I hope you are pretty comfortable with the process of finding the volume and surface area of cone. Summarizing, if we are given base radius and height of the cone, then we first calculate volume by using the formula pi r square h. However, for face area, there is a slant height requirement which can be found out by using Pythagoras theorem. After that, we can find the surface area by the formula pi r into sum of r and h. However, if it is open, then the formula is only pi rl. Sometimes we are given the volume to find the base radius. Here we have the height of the cone as 10 while the volume is 250. To find the base radius, we use volume formula which is pi r square into h. Rearranging, we can get the value of r square as shown on the screen. We get r square is equal to 160.77, and taking the under root of it gives the base radius r value, which comes out to be 23.87. Don't forget to like and subscribe for updates on other topics and new tests. Thank you.